So the thing is what we need some data to be processed, and the data, it's a mandatory that should make the data available in a local file system. And I told this yesterday. So just when we are trying to access Hadoop cluster, so we have the two things. One is a local file system as well as Hadoop file system. Both are available. So what local file system contains? The local file system always contains the Hadoop configuration files, right? Hadoop executables, the binaries, right? So all they are written to the local file system, right? Suppose you are trying to configure some new component in a Hadoop cluster, then so we use the local file system. Even the Hadoop configuration files, Hadoop binary executables, Hadoop library files will be available in a local file system. And suppose if you're trying to access the local file system from the HDFS file system, we can trying to access the HDFS from one Hadoop cluster to another Hadoop cluster. Yes, we have use the local file system commands to retrieve the data from the HDFS, right? In the sense, suppose see here, uh, you are trying to write some data into the data node, and we know that the metadata is going to return to the name node, right? My question is, where name node writes its metadata, right? So then everybody knows that, okay, so the blocks are placing into the data nodes, and we are writing the metadata or reference of the data into the name node, right? Fine. So where name node writes this metadata into the system, right? So name node writes its metadata into a local file system, and the data node, the data which we're writing as a blocks, the blocks also written into the local file system, right? So the application which we are going to configure, so they are also written into the local file system. The only the input data which we are going to process, right? So that the data should be resides into the HDFS. So when we are trying to run a job, so we should make sure that the input data must exist in a HDFS. So then only we can able to process the data. So all the time, so the application related files will be available in local file system. Hadoop related files are available in a HDFS file system. Okay, so now I want to run a job. So then first make sure that you have the data available in a HDFS, and then make sure that so you have a job execution engine, either a MapReduce or a yarn is running on the cluster, right? Because you have HDFS is running, yes, we can able to store the data. And if you have MapReduce or yarn is running, then we can able to run the job. So that is, in a Hadoop cluster, if you say only HDFS started but you have not started the MapReduce and yarn, that means you can able to store the data but you can't able to process the data. So to run a job, we need either HDFS or yarn is should be running in the cluster, right? Now we can access the yarn through the web UI, right? So we should know the port number, so you can run here. So if you write here if config, so this is right. So I'm taking this one, right? IP address. Okay, now so I'm trying to access from here 8088, right? So where yarn is available, right? So I can access the yarn page here. So whenever I run a job, so that job is going to be displayed here. Either you run a job in a Hive or you run a job in a Pig, right? So the job is taken here, displayed here. The job status, job configurations, and the job monitoring can be done through this page, right? So we can access the yarn through 8088. Now see here, so I'm taking putty to connect to the cluster. So this is my host name. Click the button open. It will ask the password and username, so which my admin provided to connect to the cluster. So here I'm using the default one, that's a Cloudera, and the password is a Cloudera. Okay, right. So now I have connected to the cluster, right? So now I want to run a job on a Hive. Then just start the Hive terminal. Okay, so I'm not going to teach here Hive right now. So we have a separate session on Hive, so that time we dig deep into the Hive. So just here see, I'm going to run a job, a sample job, how I'm going to run a job and how it is going to be displayed on the yarn page. That's we are going to see now. Okay, so here this is like Hive is similar like MySQL programming, but generally people, most of the people, so thought that thinks that the Hive is a database. Hive is not a database. Okay, Hive is just only the client API, right? Which we are going to process the data which have a similar syntaxes like MySQL. So how you write a MySQL? The same way we query in a Hive, but Hive is not a database, but MySQL is a database. So don't make the comparison, but it follows the syntaxes. To list the tables, we write show tables, right? So these are the tables which are available. Right, now you can see it. I'm taking one table named temp underscore India. So I want to run a job. So to see the data, we use select the start from temp underscore India. Right, just want to see only the 10 rows. Limit 10, press enter. Right, see this is the right some information I'm having. Now I want to run a job. So right, when I write select star from temp underscore yeah, this is query. So this is not going to be a query which is going to run on the Hadoop cluster, right? It's a simple query. It's going to display the data. But the same if I write here select count of star from temp underscore India, right? So now I'm going to perform the count, right? So when I'm trying to count the job, now this job involves map reduce, right? The data processing should be done through the map reduce. So now it's going to be a job. Hive have its ability to identify which job should be processed in Hadoop cluster and which job should be displayed directly. So when a job requires shuffling the data, when you're running some Cartesian product, or when you're performing a count operation, so these are the specific jobs or the programs which involves the shuffling the data, sorting the data, counting the data, which involves the map reduce, right? So it will identify which job requires a map read and which job doesn't require a map reduce. Now the first, when I write select start from the table name, it's simply plainly displaying the data from the HDFS, so it doesn't need any map reduce, right? But when you write select count star from the tape underscore India, now it has to count the number of rows, right? So which involves some number of mappers and some number of reducers. A process should be run, right? So that's I'm running here. Press enter. Okay, so now see when I write the query, so this query is taken as a job, right? So this is a query, so the query ID you can see here, so it involves only the one job, right? So total jobs are one. Suppose if you write a nested select statement, or if you write a giant statement which will have multiple statements, right? So then it will take the jobs as a multiple jobs. Right now it's only the one query will be taken as a job one. So this job one started here, so every job will be given as a job ID. So this is job ID, and you can track the job information with this tracking URL, right? So where the job ID is 0001. The same way we can access the job from here. So if you click here, see now this is job ID. It's with an ending with 0001, right? So this is job is running, and it's a map-ready job. It's running under the yarn environment, right? So this is a Cloudera user. So the job started this time, right? So it's a job progress. Right, so completed, finished, succeeded, history, right? You can see it now the job, right? Job execution steps here, right? Jobs launched, we have it need one mapper and reducer, right? Took this much of CPU time. So number of reads and writes performed in HDFS, right? So finally it retrieved 65,998 rows in the in here in the table temp underscore India, right? So same thing, suppose I'm running the same job again, press enter. Now you can see here, so when the job you enter, so the job is taken by the uh, resource manager. Now here it's tracking UI is assigned unassigned, the status is undefined, right? Just refresh it, so the job is given to the application master. Now see, application master is monitoring the job, right? So still the status is undefined and the job is running, right? So right, still the job is running and the job is monitored by the application master, right? Job, see the 50% of the job completed now, right? If you place the mouse pointer there, it will show you how much percentage job is completed. Right now the job is completed successfully, you can see 100.0 percentage, right? The job completed successfully. So if you click on this job, now you can see the user who initiated the job. So what is the name of the job and what's the job type? It's a map ready job, right? Job is finished successfully, right? So it took 34 seconds, and tracking URL history, right? So this is like we can able to see the job configuration, right? So when you're running a job, so like this, we run a job, it's a Hive or a Pig, right? So we initiate a job like this. Suppose if you want to run a job in a Pig, yes, can you see here cloud era, then cloud era. Okay, so I'm writing pig hyphen x map rate to start a pig, right? Pig environment, we call it as a grunt, right? So this is a pig shell, we call it as a grunt, right? So where we are going to run the pig commands. So clear. So just try to load the data. So just locate some data from the HDFS, right? So see cloud era, and the password is cloud era. So if you write Hadoop space fs fn ls, it will list the files from the Hadoop file system, right? So these are the different files are available here. So let me pick one file here, prod, then Hadoop space fs-ls prod. Okay, so here I'm having a file prod underscore info.csv, right? You can see the file content, fs-ls prod. Okay, so what is the file name here? The file name is prod underscore info.csv, right? To process the file, first we should know what the file contains, right? So here I'm running a command hadoop space fsfncat to see the content of a file. So which file? Prod and prod underscore info.csv, right? So you can see the content of the file here, right? So this is the some I'm having 5 rows, and these are the comma separated values. Right now to load this data into the pig, so I'll took some student info equal to, so I have to load the data, right? So just write load where the data is available. The data is available under user cloud era in a directory prod. So the file name is prod underscore info.txt. No, it's a CSV file, right? So just write the path where it is available, right? So it's a capital P prod underscore info.csv. Right, so this is a file I want to load into a pig variable stud info for the processing. Then you can write, you have to define the delimiter, so using pig storage to specify the delimiter, that is a comma, each field is separated by using pig storage. Then they define the schema as, right? So first is id is going to be an integer, then name is going to be a char array, right? Like this we load the data into the pig. Now the entire data from this prod underscore info.csv is loaded into a pig relation, pig variable stud info. Now if you write dump stud info, now it will show you the what we loaded the data into stud info is going to be displayed. Now you can see hit the job here, refresh the page, right? So this is the job, right, which is running right now. So the job id is 003. So the job is initiated in a pig latin, and the job is mapped to job, right? Job is running now, right? It's unassigned, right? Job is running with application master, 5% job is completed. You can see the same thing here, right? It's running here, right? The job is completed, the same, right? Job is finished successfully. So if you click the name of job, so the job name is this one, right? It's a map reduce job, and xq finished. Okay, we can see the output, right? So like this, right? So we have loaded. Suppose if you want to write something, so you can write, so I want to filter the data, filter users. So what is the schema? You can write describe student info, right? We have id as an integer, name is character, right? So you can write a condition, right? Filter id greater than 3, right? So I want to store this one, so you can write, so users new students new join equal to, we can write something like this, filtered where the data is available, student info by id greater than 3. So this is how a pig program looks like, right? Now what it will do now, so we have the data is available here, right, in the student info. Now from here I want to find out the users where id is greater than 3, that is we have 4 and 5, right? So if you see this data, then we write dump new join, right? So this is how a pig program looks like. Writing a pig program, it looks like writing a paragraph in English, right? It's very easy and simple, right? So this another job which is running created, refresh the page, now the job 4 is running, right? So job is unassigned, then the job is given to the application master, right? So it's application master monitoring the job. Okay, so like this we process the data using a pig, right? So this is like how Hive program looks like and how pig program. The same thing you can create right in Hive too. Like suppose you can create a table, create table, some prod prd. So if you want to write in a Hive, write like this. Right, so now we have seen how we generally write the programs in a pig, right? So loading the data, and that's with the load statement, displaying the data with a dump, and right, we filter the data like how we write if condition, we use here right, filtered, right? So that's, we have a separate chapter is there. I'm going to teach you the pig. Now see here how Hive program looks like. Okay, you can simply write a create, so table. So I'm going to create a table with the name stud info. Okay, just stud info. I use 1 2, right? So what is the table schema here? id is an integer, name is a string, right? Table name and table schema. Then we have to write the delimiter, like you should specify how each field is separated here, right? So here my input data, each field is separated by the comma, so we have to specify the comma as a delimiter here. To specify the delimiter, so in a Hive, in a pig we write pig storage, right? So in the same thing in Hive we write row format delimited, then each field terminated by comma, semicolon, press enter. Okay, the table is created. Now to load the data, so you can write load, so where the data is available, the data is available under the prod, right? So load data in path, where it is available, just write the path, user cloud era, then in a directory prod, I'm having a file prod underscore info dot csv into table. What is the table name here? Stored info 1 2. right? So like this we load the data. Now you can see it, select star from stud info 1 2, like dump we wrote now. So here we write select to star from, it will display the data. To count the rows, now you can write select count of star from stud info 1 2, right? It's going to be the mapper to job. Now we can check here the new job, right? Select the count star from student 1 info 2, its job is running. Right, so still the job is running here. Now it's undefined. Now the job is with application master. Okay, see now the job is completed. Now if you click here, right, we can able to see the job status, job information. Right now here in the terminal where it is. Okay, so total number of rows is 5, right? So this is how we write Hive. Okay, this base here, right? So how a Hive program looks like. So this is, and we use this statement to load the data. Right, the same way how pig program looks like. Let me copy here. So the same program in a pig we write like this. It is a pig program. Okay, if you, when we are running a pig, right? So both the times our input data is available in a HDFS file system. The data which we have loaded into the Hive variable, the data which we have loaded into HDFS variable. So I used the HDFS and I specified the path like this. You can see the Hive statement here. So what is the path I wrote here? User Cloudera prod, right? So that is by default in a Cloudera. So whenever a user creates a directory, the directory is created under user Cloudera, right? So in a directory, so this is the user directory created. So if you're working on Hortonworks, so the default location is user Cloudera, and if it is a Hortonworks, it's a user root. If it is a Cloudera, the default location is user Cloudera. That is, if you write mkdir test, then the test by default created under user Cloudera. So all the files related to user and the directories related to user by default created under user Cloudera. Now, so to access this, we have the different ways. Suppose generally I want to list the files. So I wrote Hadoop space FSFNLS, right? So what it will do now, it will list the files from the HDFS. To list the files from the specific directory, so I wrote prod, right? By default it is similar like Hadoop space FS-ls, that is the default location is user Cloudera prod. Actually this is the default location. So by default it takes user Cloudera, so we don't write user Cloudera, we write Pradera. So both are same, but you can see here actually the complete UI, right? So we access like this, right? So the to access files in HDFS, so we should use the complete URL like HDFS colon slash slash, right? So where it is available, host name, the name node, host name of name node colon, then you have to write the name node port, then the directory which we are going to access. We write like this, that is, you can see here HDFS colon slash slash. What is the host name? I don't know the host name, you forget it, then just write the in the terminal. If you write host name, it will list the host name. So this is the host name, and if you know the IP address, if config will display the IP address. Now you can use anything, either you can use host name or you can use the IP address. Okay, so here what is the host name? So this is a host name. Okay, so I'll write HDFS colon slash slash, then write the host name colon, so the port number for the name node, that is 8020, then write user cloudera, then prod. So like this we can access. See here, I'll show you here directly. Clear the screen. So first you can write Hadoop space fsfnls prod, it works. Okay, so you can also write Hadoop space fsfnls user cloudera prod, it works, right? So you can write Hadoop space fs-ls, the complete URI. You can write hdfs colon slash slash, then write the host name. So what is the host name? That is quickstar.cloudera, and the port number it's available on 8020. Then write user, then cloudera, then prod. So like this we can access. It's a complete URI, right? Suppose if you don't know the host name, if you know the IP address, then you can write the Hadoop space fs-ls, then hdfs colon slash slash, and what is the IP address? Right, so write the IP address colon name node port, that is 8020, then user cloudera prod. See, now we can access this many number of ways to in a file which is in a HDFS. Okay, right, so to access the files in HDFS, so you can use anyone. Right, so this is how we're going to access. So suppose you are in one Hadoop cluster, then you are trying to access a Hadoop cluster. So generally we use this complete URI. If you're working in the same cluster, you're trying to access the file system. So generally if it works, they just write a Hadoop hdfs colon slash slash host name something you can write. Otherwise you can write Hadoop space fsfnls and user cloudera prod, both works. But suppose here, generally when we use a complete URI, suppose I'm in a one file system and I'm going to access the Hadoop, another Hadoop cluster files. I'm having the privilege to connect to that cluster, so I want to list the files, right? So then generally we use this complete URI to access the files from the HDFS. Okay, so now if you want to access a local file system, we can also access a local file system like this. Clear the screen. So if you write Hadoop space fs-ls, right, so in another cluster where I'm working, so you can access the file colon triple slash to access the local file system, right? So these are the files ls, right, the files which are available locally, right? So we can access the local file system with a representation Hadoop space fs-ls, and we use file colon // okay, right. So now to work with the files which are available in Hadoop file system, so we have given Hadoop file system API, right? So what Hadoop file system API? So file system API, right? So which contains some set of commands which we can able to transfer the files from the local file system to HDFS file system, as well as Hadoop HDFS file system to local file system, right? So in a Hadoop file system, to work with the files, see, actually this Hadoop file system API is a utility which is invoked by with the command Hadoop space fs. So when the Hadoop is configured, so by default Hadoop is available in Hadoop home, which is user lib is the default location in the cloud area. So you can see here, clear the screen. If you go to cd/usr lib, now we can see Hadoop here, so where Hadoop is configured. So this is Hadoop home. So if you go to cd Hadoop, press enter ls, then you can see the bin directory, right? All the binary executables are available. So clear the screen, ls, now cd bin ls. Now see here, so these are the executables. So this is the Hadoop API. So the commands which comes with the Hadoop, right? So if you write Hadoop space, press enter, now you can see the list of commands which Hadoop will take, right? So first it run a Hadoop space fs, and it run Hadoop space version, right? So and other commands. So here Hadoop fs, which invokes a file system client, right, where we can able to work with the Hadoop file system, as far as that means we are going to work with the Hadoop environment. So you can see here, if you run Hadoop space fs, press enter, right? Now it will display the list of the commands which are available with a Hadoop file system. That means now only these are the commands which are available, which we are going to work with the Hadoop environment. So now you can see if any command is there or not, right? You have a confusion, then just write the command Hadoop space fs, press enter, then whatever the commands it is displayed. So only these are the commands which are available, which we are going to work with, work to access the Hadoop cluster. So we have a limited set of commands are available. So generally you may have a confusion, because we have so many Linux commands are there, and most of the Hadoop commands are right, so which is taken from the Linux. So you have a confusion, it's there in the Linux, but it's there in the Hadoop or not, right? So if you run Hadoop space fs, so it will list all the possible commands which are available. So only that commands are available, and only we use those commands to work with the Hadoop file system or Hadoop environment, right? So in this one today we see the basic commands, right? So any Linux command, right? Mkdir is a Linux command. For this, if you add a prefix Hadoop space fs hyphen, right, then this command becomes a Hadoop command, right? So most of the Linux commands, if you add the prefix Hadoop space fs hyphen, then that command becomes the Hadoop command, right? So if you write Hadoop space fs hyphen mkdir, so it will create a new directory in HDFS. Okay, so see now, because if you write only mkdir, it creates a directory in a local file system. But if you write Hadoop space fsf and mkdir, it creates a directory in Hadoop file system, right? So and to list the files, we have the command Hadoop space fs-ls. So what it will do, it will list the files from the Hadoop file system. So if you write here Hadoop space fs-ls, now it will list all the files which are available in HDFS. Okay, now when you write here, so it's a little bit difficult to read the file size. What is the file size? It's very big, right? It's a little bit difficult for me to read. So now Hadoop fs-ls will take the two parameters. One is -r, right? What it will do, it lists the files, it lists the three kind of structure, right? It will list the directory, then subdirectory, and the files in the directory is going to be displayed. with a size. And if you write -h, right, it will list in a readable format, that is it lists file size in kilobyte format. Okay, so if you write -ls-r, it will list all the directories and subdirectories, and if you write fs-ls-h, it lists the files in kb format, right? So now you can see here this file is very difficult for me to read. What is the file size? Then I have to convert. So instead of that, I use the command hadoop space fs-ls-h. I'll write here, press enter, then it will display the file size in kilobyte format. Now see here, so the file is right now 16.6 MB, right? Previously we got a big number 17194567 something, right? Now it's converted into the KB format. Then the file size is 16.6 MB. Now we can see here all the directories, but what are the files are there in Ajay, right? So it doesn't display. So I want to display the directory and subdirectory and files in the directory. Then you can use -r, right? So -r, that's right, -r, then -h, right? It will display the directory, subdirectory and files in the directory, and the files is in kilobyte format, right? Now we can see it, we have the directory newbie, so and the files here newbie 1.txt 1x.csv, and these are the file sizes, right? Each directory and the files in the directory is going to be displayed, right? So h3 is a directory and these are the files, h4 is a directory and these are the files. So like this it will display, right? Yesterday we created newbie and we have copied the two files, one is f2 and other one is table comparison.sh, right? Now we can see the directory and the files in the directory, right? So which command I have used here? So ls is generally to list the files. We'll take the two parameters, one is -r and other one is -h. Okay, and see here, when we discussed here, so to ingest the data to the Hadoop cluster, to write the data to the Hadoop cluster, so we have the commands are available, right? To copy the files from local file system to HDFS file system, we use the commands hadoop space fs-put is a command which copies a file from the local file system to Hadoop file system, and you can also use hadoop space fs-copy from local, which copies a file from the HDFS to, sorry, from local file system to HDFS file system. Okay, and you can use hadoop space fs-move from local, right? Which will move a file. So copy from local is like copy paste, move from local is move, right? It will move a file from the local file system to HDFS file system. And the reverse, we can also copy files from HDFS to local file system, right? So the commands here, it's a put here. So the reverse is you can use hadoop space fsfn get, right, to copy a file from the HDFS to local file system. And then you can also use hadoop space fs-copy from local, right? Here it is copy to local. So this is a case sensitive f and l capital, so here t and l is capital. And the same thing you can use hadoop space fs-move to local, right, to move a file from the HDFS to local file system. So we use these commands to copy the files, to transfer the files between the local file system to HDFS file system and HDFS file system to local file system. See here, ls, so let me go to the home Cloudera and in a documents ls, right? So I'm having some files here. Okay, so see ba.txt is one file. I'll use India versus Pak.txt. So now I want to copy this file to the directory newbie in HDFS. Then I use the command hadoop space fs-copy from local, right? Here F capital and L capital. So hadoop space fs-copy from local. Now which file you want to copy? I want to copy the file India versus park.txt. Where I want to copy? I want to copy this file to user, then Cloudera. So I have a directory newbie, right? So I want to copy this file to HDFS directory newbie. Press enter, right? So like this, we can able to copy a file to the HDFS from the local file system. To see the file, you can write Hadoop space fsfnls. If you write newbie, it will show you the India versus park.txt. User, no, it's a wrong path I gave. The second space fsfnls. We have newbie here. Newbie is a capital one. So here newbie is a file, not a directory. Where created this one? N capital and B capital. Right, it's a directory and we have copied the files yesterday, right? So now you can run the command Hadoop space fsfn copy from local the file which we want to copy and where you want to copy. Press enter. Now this file from the local file system copied to the HDFS file system. Right, now we can see here Hadoop space fsfnls new B. Right, the same way if you write move from local, it will move the file, right? Move means it's like cut paste, which will not exist in the source but copy to the destination. The reverse, right? So you can use Hadoop space fs hyphen copy to local, right? So what it will do, copy to local will copy a file from the HDFS file system to local file system. So first we have to write the source location. So where I want to copy, I want to copy the file from the HDFS. So the location is, you can write user Cloudera. Right here I'm having the directory newbie. So in the directory newbie, I'm having a file. So which file it is? India vers park.txt is the file name, right? So this is the location and the HDFS. Now specify where you want to copy in the local file system, then write the path home. I want to copy this file to Cloudera. Press enter. Now the file is copied from the HDFS to local file system, right? Successfully. Then you can see it Hadoop space cd home cd dot dot, I'm in home Cloudera. Now you can see ls. Now we can find here India versus park.txt. So like this we can copy a file from the HDFS to local file system as well as local file system to HDFS file system. Okay, so we use the syntax here, copy from local and the reverse, copy to local. Right, so this is the syntax. You can use put also. Put also works the same thing, right? Copy from local and put works both the same way, right? You can see here Hadoop space fsls to pick a file. Now I use another file here, f2, right? So I write Hadoop space fs hyphen put. So put also copies a file from the local file system to HDFS file system. I want to write the file with the name f2 to the directory newbie in HDFS. It already exists. Okay, so I'm writing Hadoop space fs hyphen put. So I use the file ba.txt to the directory newbie. Now the file ba.txt is copied to the directory newbie. right? So you can use Hadoop space FS7 put. Okay, and we have a command, cat command. So what cat command will do? Hadoop space FS7 cat, right? It will display the content of a file. So if you write Hadoop space FS7 cat, now I want to see what I'm having in the file newbie. So prod underscore newbie. Now we can see the files in the directory newbie. Then write Hadoop space FS7 cat. Then in a directory newbie. Then int words park.txt. Press enter. So cat will display the content of the file. Right. So these are all the matches played between India and Pakistan. Right. So we use this file to run some queries or to analyze the data. So I'm having this from 1983 to 2016. Right. So these are the statistics between the matches played between India and Pakistan. Right. So we use the command Hadoop FS7 cat to see the content of the file.